Have you ever thought about mining? No? Okay. Before batteries were available to light miners' lamps, they used a substance called calcium carbide, and they would drip a little bit of water on it, and the water would react with the calcium carbide and generate acetylene, and the acetylene would burn in their little, their little torch headlamps so they could see in the mines. Today we're going to fill these pumpkins with acetylene from calcium carbide and water, and we're also going to use yeast to make hydrogen peroxide turn into oxygen and water. Have you ever put hydrogen peroxide on yourself and you've seen it start to bubble? Yeah? That's the hydrogen peroxide decomposing from H2O2 into O2 and H2O. So we're going to be generating oxygen and acetylene in these pumpkins. And if you'll recall what happened with the hydrogen oxygen balloon, we can predict what's going to happen here. No surprises, they should blow up. I will tell you, these are smaller pumpkins than we usually use. It's after Thanksgiving, so we can only get the baking pumpkins, not the big jack-o'-lanterns. So it may be a little bit, it may not be quite as big a bang as you've seen in the past years, so that's why the pumpkins are a little smaller, hold less gas. So let's get started. Calcium carbide. Calcium carbide is a solid because calcium carbide is an ionic compound. So this is what calcium carbide looks like. I'm not going to pass it around because it's very reactive and it will mess up your skin. So we're not going to do that. I've already put the yeast in the pumpkins. Some pumpkins have enough of the right kinds of enzymes in them to disproportionate the hydrogen peroxide on their own. I've never had any luck with that. Some of my colleagues at other schools say they can get it to work. I always have to add some yeast. So put in some calcium carbide. Here's this pumpkin has a small hole in the bottom. Oh. Don't worry, it'll still explode. It's just some of the liquid is going to leak out of the process. Just don't touch it, everything will be fine. Now I will tell you that when you're doing this, if you ever see anybody do it, you don't want to use one of these because every once in a while the fire shoots out the back of the pumpkin. And that happened to me one time, and my whole arm looked like Wile E. Coyote from here down. All the hair was gone, completely black. So I've modified the procedure to one of these. That way when the fire shoots out the back, somebody over here gets turned into Wile E. Coyote and not me. Okay, good. So now I need to go bring the father. So I've cut a small hole in the back. I've cut a small hole in the back so I can put the grill lighter in. And I've cut some holes in the front. Now I'm going to point this thing this way so nobody gets hit with pumpkin shrapnel. Okay? Are we ready? Okay? You might want to, I don't think you'll have to cover your ears, but if, okay, on three. 1, 2, 3.
Whoa! That one got distance.
Well, like I say, sometimes size doesn't matter. That's, okay.
Were you expecting that?
No.
Okay.
I was expecting it to go bang. Not quite like that.
That was fun.
That's a bit more exothermic than it normally is. So, Dr. Tisich, good pumpkins. This one's a little smaller, so I'm just gonna vent a little gas. So we have something left at the end that's not just shrapnel. Okay, here we go again. That's what's supposed to happen. So,
Well, I'm glad he got it.
the pumpkin is intact.
Aww.
Yes. Only one pumpkin was murdered in this experience. Okay, thank you.